All right, number 35 from chapter 16, a capacitor problem. So look, the key to doing these circuit problems, as I've been saying, is to do simplified pictures. Now what I'm going to do is I'm going to erase the text up here just so we have more room to work. The key to doing these circuitry problems is to draw simplified pictures. So what the question said is to find the charge on each of these four capacitors. So I'm going to scoot this up to the top here. Now, to figure this out, you got to draw simplified pictures. So what I'm going to do first is I'm going to simplify these two and these two. So these two guys, the 1 and the 5, are in parallel because the circuit branches right there. And then the 8 and the 4 are in parallel because the circuit branches. So how do you simplify capacitors that are in parallel? You add them. So this simplified picture is going to look like this. So we got capacitor, capacitor, hooked up to a 24-volt battery. Okay, so a 1 and a 5 in parallel, that's going to be 6 microfarad. An 8 and a 4 is going to be 12 microfarad. All right, then we only have one more picture to do. So our final picture is going to be, so simplifying two capacitors in series, how do you do that? The 1 over equation. We're going to go 1 over the equivalent equals 1 over 6 plus 1 over 12. When you do the algebra and solve for the equivalent, you're going to get 4 microfarad. All right, so now, how do we figure out the charge on each of the capacitors in the original diagram? So we're looking for the charge on this guy, this guy, this guy, and that guy, where Q is charge. So what you got to do, you're going to start at the most simplified picture. You're going to start with this picture down here and work your way back. So we can figure out the charge on this simplified diagram. Like, what's the charge on that capacitor? So we're going to use the definition for capacitance. Capacitance is charge over voltage. So charge is capacitance times voltage. So the capacitance here is 4 microfarad. Now, look, I would just leave the micro there. What's a farad? A farad is coulomb per volt. So it's like 4 microcoulombs per volt. Now, how many volts are across this capacitor in this last diagram? It's 24, right? Because positive plate, negative plate, the positive plate's 24, negative plate is 0. So over here, we have 0 volts. Up there, we got 24 volts. So there's 24 volts across that capacitor. The volts cancel, and we end up with 96 microcoulombs. All right, so that's the charge on that simplified capacitor, which tells me the charge on this guy and the charge on this guy must be 96. It's the same logic. It's the same logic as if these were resistors. So imagine for a moment that these guys, instead of being capacitors, imagine they were resistors. If you found the current through the most simplified resistor here, then you found the current through these guys. Okay, it's the same logic. All right, so now let's go up to this diagram. Now, if we're going to find what these charges, so we have 4 capacitors up here. So we're going to be using this equation, right? So charge is going to be capacitance times voltage. We already have the capacitance of each of the capacitors, right? We already have this C right here. So now what we got to figure out is what's the voltage across each of these capacitors. Does that make sense? So how do we do that? Well, we're going to do that on this picture. We can find the voltage across each of these. So let's do that. Let's find the voltage across these guys. So all we're doing is we're using this equation right here, and we're solving this equation for delta V. So delta V is going to be Q over C. So let's do that for this guy right here. So what is that? I gotta do it. So Q over C, that's going to be 96 over 6. So we get 16. And then for this guy, it's going to be 96 over 12. So this is going to be 8. So look, here's how it works. Again, 24 volt battery, it's like this. 24 volt, 0 volts. So how many volts right there? 0. How many volts right there? 24. So this point right there, that little dot right there, that little dot is 24. This little dot right here is 0. Now what happens when you cross this first capacitor? We're going to lose 16, which means that this point right here would be at what? 24, and we lose 16, so that's got to be 8. Then you cross the next capacitor, and we lose what? 8, which brings us back to 0, which is where we should be, right? Now, let's do the same thing up here. Same thing, 24 volt, 0 volt. So how many volts do we have right there? 24. How many volts do we have right there? 8. How many volts do we have right here? 0. It's the same thing, right? Same exact thing we just did right here. So look, what is the delta V across that 5? 16, right? 24 down to 8 is 16. What's the delta V across the 1? 16. Voltage in parallel is always the same. Okay? What's the delta V across this 8? 8. What's the delta V across this guy? 8. Do you guys follow this? Okay. So, now how do we figure out these charges? Now all we do is we go to this equation right here. Charge is capacitance times voltage. So we're going to go 8 times 4. That's 32. Up here is going to be 8 times 8. So this charge on that plate is going to be 64 microcoulombs. Okay, up here the voltage is 16. 16 times 5 is 80. Yeah, 80 microcoulombs. And then this guy right here is going to be, what's the voltage? 16. 16 microcoulombs. So we got 16 microcoulombs, 80 microcoulombs, 32 microcoulombs, and 64 microcoulombs. So the way we did this, break it down and then work your way back. Any questions on this? Yo. Oh, they were given. The capacitance, that's like the 1 microfarad and the 8 microfarad. Is that what you mean? Yeah, those were given.